Hi Danny. Assignment 1, Mechatronics. It's on the critical evaluation and selection of actuating sensor technology for a mechatronics application. So it's about 2,000 words in length you need to think about doing. And I've put an issue date of today and hand in 4 weeks time, because we've got a week's holiday. I thought I'll allow that as well, so hand in on a Thursday 4 weeks time. There's an online submission point already put up there, and there's a brief on the site as well, should you lose the one that I've given you and need to get another one. Alright, so it covers the learning outcome that you are to be investigating, critically appraise a range of mechatronic actuators and sensors. Okay, and I know we ain't done anything about sensors yet, but we will be. I'll be doing a little bit about them anyway. So, what we got then on the next page is the grading matrix. Just change the view a little bit so you can see it. Three things I'm looking for really. First of all, analysis of a range of options for actuators to provide rotational motion for a mechatronic system. So you're going to analyse, we've had a little bit of a look at stepper motors, but you're going to do, through research, compare those to another type of drive, probably a servo motor, and anything else that you think might be suitable for the particular application you've been given. Okay, and I always like to look down the second upper line and have a look at what that says. Second upper line says the report provides highly justified angular motion solution. The solution is strongly linked to excellent critical analysis of the technical aspects of providing angular and rotational motion. So when I say linked, you know, what you're saying, your justification should be based upon what your analysis of the two different types of motor are, because quite often what I get in assignments, there isn't that link isn't there. Okay, and whenever I say critical analysis, it means that there must be a balanced argument. The key point there is have you also addressed the disadvantages as well as the advantages of what you're proposing. So if the balance is not there, if all you're thinking is all the good points and you've not considered what the bad points are and their disadvantages, then the mark's going to drop down. And that's true of anywhere where it says critical analysis. Second thing you're being assessed on is critical analysis of the options for sensing angular and rotational position movement. Okay, and in the second upper line there it says the report provides highly justified angular measuring solution. The solution is strongly linked to excellent critical analysis of technical aspects of sensing angular motion and rotational position. So similar words there really. Alright? And I always think second upper or merit at foundation level is where you've done everything I would have expected you to have done at this level, and there's not really anything missing. To get in that top band, we're looking for me to go, oh, wasn't expecting to pick up on that, or that's exceptional that they're included, that explanation and those diagrams of how it all works. It's not even necessarily even a way I would have thought of presenting it, and that's what will lift it up into that final first bracket. Okay, yeah. And then the last thing, and that's always at the bottom of every grading matrix that I do, that's the overall presentation and referencing. And again, in the second upper situation, excellent level of presentation, accessible to the majority of intended readers. Majority of sources are referenced fully to the required Harvard standard. That includes an in-text citation with a full reference at the end of the document. And I think you know how to do that by now. Been with me long enough. Yeah. So that's just 3 key areas that I'm going to assess in this assignment. Keep it simple. Alright? So, going a bit further down the assignment, have a look at what I'm asking you to do. Bit of a sort of preamble. Mechatronics consultant, hired by a small engineering company, undertakes a range of automated operations to manufacture a wide range of products. Company currently uses an automated drill and turntable system to drill holes in plastic flange spaces. Current system uses pneumatic actuators to operate both the drilling operation and rotating the turntable to indexed positions. So the current system, as it stands, is able to cater for a small range of different hole pitches and is adjustable to allow for different pitch circles. So at the moment, there's only a range of different angles they can achieve, but and even doing that is by having to change part of a mechanism underneath so that it operates mechanically to a different angle, pitch between circle, so allowing for different numbers of holes in a spacer. And the drill position is adjustable here, backwards and forwards, to allow for different diameters. It's proposed that that is going to stay the same. We're not looking at changing that at all. Okay. However, to change between pitch drillings is somewhat cumbersome and requires parts to be changed in most cases. With this in mind, the company envisages that the current system be updated to more easily allow for drilling holes around the space at different pitch angles. Basic diagram of the current system shown in figure 1. Yeah. So that's where we are. That's a reasonable basic diagram of what we're looking at. All right. And the drill goes up and down on a rodless pneumatic drill operation. Not proposing to change that at all at this stage. Might, however, be subject of a future year's assignment. All right. So, moving on down. You've been hired and commissioned to provide a short technical analysis of the current system of actuators and associated sensors and propose a new design that incorporates electrically actuated turntable, improved sensing technology. Engineering manager are likely to discuss implementing these changes using either servo drive or stepper motor technology, but recognises there are a number of different types and so requires your guidance on which ones are suitable. Yeah. We've already seen that there's 3 different general types of stepper motor, and there are other different things that you can do with those that I've left you to go out and research, and there are different types of servo drive, and they work in a completely different way, which I'm leaving you to find out about as part of this assignment. Yeah. So, assignment requirements. It's in 2 parts. Oh, come on. Part 1. Electrical operation of turntable. For this part of the assignment, you're required to write a report to critically analyse and evaluate the use of servo drive and stepper motor technology to operate a drill turntable in specific angular steps. Yeah. So, in about 1,000 words, you might include the following details as you feel appropriate. Types of motor and drive available, what their advantages and disadvantages are, with a recommendation of a suitable one for the application described. Short explanation of how your chosen solution operates, detailed information on how the control signals are produced is not required for this report. So you're not, you might look at the switching algorithm a little bit that we're going to look at later, the basic, what you have to do on the 4 inputs or whatever they are, but you're not expected to look into how a controller would produce those very quickly to get it to run. That's not what this assignment is about. Okay. A clear analysis of the angle steps that could be achieved with your recommended solution. So they've only got a small range of angles they can work with at the moment, so they're interested in knowing what resolution they would be able to work to with this system, bearing in mind that, you know, the holes are certain size anyway. We're not looking at having a chain drilling. A clear indication of the torque that can be achieved with your solution, and whether there's any need for separate devices to hold the turntable during drilling. So is there any need to hold that still mechanically while it drills in each position? And you saw last week that there's a Holden torque on the stepper motor, but whether there is on a, whether you can achieve that with a servo drive, that's for you to find out. Okay, and what sort of torques can we achieve with this system? It's not got to turn a particularly heavy load anyway, but you might want to consider how much Holden torque you got there. Right? Part 2. Analysis of turntable position sensing indexing devices. As described earlier, drill and turntable rotates to index positions using a mechanical indexing system. It's thought that with an electric motor solution proposed in part 1 of this report, a precise method of positioning the turntable is required that will allow a particular pitch angle to be moved to for each hole that is drilled. I mean, that option means that they could actually have holes unevenly spaced around a pitch circle if they wanted to, couldn't they? Yeah. So if you had a plate that needed to be fitted a certain orientation, that's one way to ensure it, is to make the difference in pitch on one pair of the holes different to all the others, so that can only go that way round. Yeah. Okay. The engineer and manager is aware that a shaft encoder might be a possible solution, but is unsure of the following. Firstly, whether to use an absolute or relative position shaft encoder for this application, whether there are any other suitable options for reliably sensing the position of the drill and turntable. So, for this part of the assignment, you're required to write a report 2. Critically analyse and evaluate the options for sensing the angular position of a rotating turntable. Yeah. This section of the report should be approximately 1,000 words in length and consider the following areas: the operation and advantages and disadvantages of incremental and absolute shaft encoders, the operation and advantages and disadvantages of any alternative options for angular position sensing, and a justified recommendation of a sensor solution for the drill turntable. Yeah? Does that sound okay?
Yeah, that's good.
Yeah. For both parts of this report, you are not required to specify a specific motor or sensor solution and or indicate how they would fit together as a solution. However, you may need to indicate if any kind of gearing or belt drive is required to provide suitable rotational resolution for the turntable. So what I'm saying there is you're not required to say how it would fit together, be mounted, or anything like that. You're not required to say how it would fit in the envelope of that machine. You've got no dimension details anyway. But if to get the angle steps you need, or the drive requires you to have any kind of gearbox or belt drive, then you should be saying that and how that's going to affect the angles that you can achieve. Okay?
Yeah.
Yeah. So you might go direct drive, you might have to run through a gearbox. Right? But that's your choice. Lastly, the usual general requirements should be up to 2,000 words in length, Times New Roman or Arial, size 12, 1.5 line spacing, la-di-da-di-da, Harvard referencing system. Okay? Please make sure all diagrams are numbered and labelled. If not referred to in the text, they probably shouldn't be there anyway. We're not looking at adorning the page with pretty pictures at level 6. Alright?
Yeah.
Have you got any questions that you'd like to ask?
No, I don't think so. I'm seeing so that.
Okay.
Let's get the research in.
Yeah. We're going to have a little bit of a go this week at running or operating that motor with the switches, and have a look and see whether we can do a little short Genie or PLC program to get it to turn one way and the other, if we can get that to work. Next week we'll have a little bit of a look at sensors, position sensors and stuff. I don't want to do too much because I want to leave you stuff to research. Alright, not next week, a week after. I know we've got a holiday next week.
Yeah.
Alright? So hopefully you're alright with that, Matt. If not, I'm sure you'll let me know.
Yeah.
Hey.